in this short video today we're going to look at SIMS by Mannok. What is it and how does it perform? So SIMS by Mannok is a unique offering for builders in Ireland which combines the benefits of Mannok AIRCRETE blocks with a certified external insulation system. It's a straightforward construction method which utilises the simplicity of solid wall construction whilst enhancing the thermal performance and weather tightness of the building. So what actually is it? This little diagram gives a breakdown of what it is. So essentially your structural component is your Mannok AIRCRETE block. It's a 215 wide block, 215 wide by 215 high, so it's much larger than your standard dense concrete block. As I said, that's your structural component. Inside then that's finished with either plasterboard on dabs or on battens or by wet plaster. And then outside that your external insulation system which comprises of for example Mannok EPS insulation. Onto that then you put a base coat and a reinforcing mesh, and then over that you put your finished render, which can be an acrylic or silicone type or monocouche render. There's a range of finishes available. So very straightforward method of construction. Just looking at the Mannok AIRCRETE blocks, what exactly are they? They're autoclaved aerated concrete blocks. They've got a unique microcellular structure. The blocks is filled with tiny pockets of air. Those air bubbles are formed through a chemical reaction between the aluminium and the lime in the mix, and that chemical reaction gives off hydrogen gas which forms these millions of bubbles which give the block its lightweight and thermal properties, yet it doesn't compromise the strength of the block. As you can see there, we have a range of block strengths starting at 2.9 Newton and going up to 7.5 Newton. 7.5 Newton is the same strength as a standard dense concrete block. So as I say, the fact that the blocks are lightweight, it doesn't compromise their structural performance. And the thermal performance of those blocks, they're up to 10 times better than that of a dense concrete block. So just briefly looking at some of the benefits of SIMS. Excellent thermal performance. We're going to cover most of these in more detail later. Excellent thermal performance, superior fire performance, enhanced airtightness. An AIRCRETE block itself is more airtight than a dense concrete block. I suppose airtightness in a masonry wall, the weak place is the mortar joints between the blocks. So whilst the airtightness of the block itself is much better, you'll still likely need to coat the inside of the wall with either a wet plaster or some sort of an airtightness spray or paint or membrane. Cost effective. We've had some independent analysis done comparing different wall constructions, SIMS versus traditional cavity versus timber frame, and we'll look at those a little bit later on and where SIMS fits in there. Rapid build, building a single leaf wall versus a traditional cavity wall can be up to 60% faster. So again, that's a huge positive, and zero condensation risk because you're wrapping the outside of the building with insulation. You're limiting the risk of condensation there. Why is it so important to get the best possible solution for our walls? Up to 35% of heat from the home is lost through your wall. So that's the biggest heat loss through any element of your home. And it's important therefore to address that and get the best possible solution there. Up to another 35% in fact can be lost through thermal bridges at the junctions with your wall, so your floor to wall junction, your wall to roof junction, etc. So the method of construction of your wall again has a huge influence on your thermal bridging losses, so very important to pick the best available solution for your walls. So we look at the thermal performance of SIMS. External insulation is extremely efficient because you're wrapping the outside of your structure as such with insulation. You're essentially wrapping it all up, keeping it warm, and limiting your heat loss through thermal bridging. So as I say, external insulation, very, very effective way of insulating a building structure. No risk of thermal looping. Sometimes if insulation is not fitted correctly in a cavity, you get airflow up the back of the insulation, which is known as thermal looping, and it reduces the effectiveness of the insulation. So by building the wall and fitting the insulation on the outside afterwards, you're reducing or eliminating that risk of thermal looping. Excuse me. And you're not relying on your block layers to fit the insulation. The block layers build the blocks. A qualified person comes along afterwards then to fit the insulation. So generally it's done a lot better. There's no restriction on insulation thickness. Typically your cavity insulation, you're restricted to the width of your cavity. Typically cavities nowadays are 150 millimeters thick. So you can put up to maybe 110 mil of partial fill insulation in there, or 150 mil of full fill insulation. If you're putting the insulation on the outside of the wall, there's no restriction whatsoever on the thickness of the insulation. So again, a very good option there. Again, as was talked about thermal bridging, by building the structural element of the wall with AIRCRETE blocks, thermally efficient AIRCRETE blocks, your thermal bridging is taken care of by default. You don't have to worry about any of your junctions where you're going to lose heat loss. That's all taken care of. And then just looking at the wee table there on the U values you can achieve, typically with the 215 Mannok AIRCRETE block, 140 millimeters of grey EPS insulation. Outside that achieves a U value of 0.18. Getting down to passive level then 0.15, 170 mil of EPS will achieve that. And if you want to go further still, 200 mil of grey EPS gets you down to a very low U value of 0.13. So range of options there, and as I say, no restriction to the thickness of insulation you can put on. Structurally, again, a very good option. We've had an independent study carried out to compare single leaf AIRCRETE block with traditional 350 wide cavity wall construction. And as you can see there, we carried this out over a range of thickness and strengths of block, and 7.5 Newton block, as you can see there, is up to 3 times stronger than traditional cavity wall construction. So there's often a perception there that because the blocks is light, the wall is not as strong, but you can clearly see there that it is the 215 solid or single wall is still structurally adequate, more so than traditional cavity wall construction. And all options there, including obviously the traditional cavity wall construction, is way ahead of what is required from a typical loading requirement. This analysis was done on AIRCRETE blocks built with thin joint mortar, but again, they can also be built with traditional mortar as well. Fire, 215 Mannok AIRCRETE block achieves a 4-hour fire rating. Compare this to a timber frame which achieves half-hour fire rating, and a 4-inch dense block achieves a 2-hour fire rating. So that again is a big benefit. It's up to 8 times better there than the timber frame construction. So big positive for this solution as well. Speed of build. As you can see there clearly in the diagram, traditional cavity wall construction, you've got There you've got 6 dense blocks to build to achieve that height of a wall. If you use the Mannok AIRCRETE blocks 215 by 215, you've only half the amount of blocks to build. So already you're cutting your construction time in half for building the wall. The block layer doesn't have to fit any insulation. Typically there's no DPCs to go in around windows and doors, so again that will speed the block laying process up. It can be up to 60% faster than traditional cavity wall construction, so again that's a huge benefit. Cost, we touched on this previously. We've done some analysis, independent analysis, to show that SIMS is up to 20% cheaper than timber frame construction, and currently with the cost of timber rising, that actually might increase. That differential between timber frame and SIMS may increase going forward. So from a cost point of view, it is cheaper than timber frame. It's more expensive than traditional cavity wall construction, which is essentially the most cost effective or cheapest way to build a wall, but it doesn't bring with it a lot of the benefits that SIMS does. Again, we've touched on condensation, wrapping the outside of the building in insulation, and reducing thermal bridging by having a wall built with a thermal structural element. Means that the surface temperature of your junctions is going to stay high. Lower surface temperatures of these junctions can mean that water vapour can condense on the cold surface to form water droplets and then mold growth, which is very unsightly and, more importantly, very unhealthy. So by using SIMS by Mannok, you're more or less eliminating the risk of this condensation and mold growth. Thermal mass, we would argue that AIRCRETE blocks have got an optimal thermal mass. Thermal mass is where energy from the sun is absorbed, coming through typically south facing windows. It's absorbed by the heavier components in the room, for example your concrete floor and your walls. What that does is, during the day when there's a lot of energy coming in, it prevents the room from heating up too much, because your concrete or heavier elements absorb some of that heat out of the room and store it. And it stores it then until evening or night time, when temperatures start to drop. Then that stored energy dissipates back out into the room and keeps the room warmer for longer. So essentially you're flattening the curve. There's less irregularities or lower peaks and troughs in the curve from high temperature to low temperature. So that's a positive for concrete or AIRCRETE blocks in the structural component of the building when compared to light forms of construction like timber frame or light steel frame. The other benefit that the AIRCRETE on the inner surface of the wall gives you is faster thermal response. So here we're comparing it to say a dense block. A dense block, when you come into your home and switch on the heating, if your house is cold, switch on the heating, and your heat from your radiators or your underfloor heating starts to warm up your room, the dense block will absorb some of that heat. So it will take your house longer to heat up, whereas the insulating AIRCRETE block won't absorb that heat as quickly, so your room will heat up quicker than that if it had the dense block in the walls. So what we say there is that the AIRCRETE block has the best of both worlds. Where it has a good element of thermal mass, it also has a faster response time, a heat response time to a standard dense concrete block. From a sustainability point of view, AIRCRETE blocks are a very sustainable product. They're manufactured with up to 80% recycled material, which is always good and going to give a lower carbon footprint for the block itself. And building a home using Mannok AIRCRETE blocks, obviously then your home's going to be more sustainable overall, which is what people are looking for today. Our Mannok AIRCRETE blocks were among the first products in Ireland to have a third-party verified EPD. Those are hosted by Irish Green Building Council or on the EPD website. They're available there to have a look through and see how the blocks perform from a carbon footprint point of view. They've also got an A+ Green Gate rating, which is very good, and most of the materials in the blocks are sourced locally from our own quarries local to our production facility. Some of the smaller elements, for example aluminium and lime, are brought in small quantities from further afield, but the majority of the raw materials are sourced locally to our production facility. So again, that helps with the carbon footprint of the product. And as well as that, because of the lightweight, the carbon intensity of the transport is a lot less. We can fit an awful lot more blocks on a load and transport them to site than you would for a dense block, so that makes them a more sustainable product as well. Just looking at some recent projects that were done using SIMS by Mannok. This house here was recently featured in Passive House Plus magazine. It's a detached house in Dublin, and it's the first house in Ireland to be built to Passive House Plus standard. And the walls of the house were built using single leaf Mannok AIRCRETE blocks with external insulation, so essentially SIMS. And the estimated annual energy bill for this particular house is €393 per year, and that includes an electric car charger, so it's very, very low annual energy consumption. Another house then that was built a few years ago using the same wall construction. This house was built in Cork City, and it's the first house to achieve a gold standard in the Home Performance Index, and it's also got Passive House certification, and as I say, it was built using single leaf Mannok AIRCRETE blocks with an external insulation. So it's these two firsts for Ireland, I suppose. First Passive House Plus standard, and first achieved this gold standard Home Performance Index. It's no coincidence that both had the walls constructed with Mannok AIRCRETE blocks and external insulation. So just in summary then, how SIMS compared to the two other popular forms of construction on the market. As you can see there, SIMS speed of construction is very, very fast. It's got an excellent thermal performance, which we've covered, excellent structural performance, up to 3 times stronger than traditional cavity wall construction. It's got 4 hours fire rating, and from a cost point of view, we would say that it's the best value for money. Timber frame then, rapid speed of construction, it is very fast. It's got a good thermal performance. Structural performance there, we would say it's fair. Falls down a lot on fire performance. I suppose it achieves 30 minutes fire rating in the walls, and it's typically the most expensive. And then moving on to traditional cavity wall, it's the slowest form of construction. Thermal performance fair, can lead to issues with thermal bridging and insulation not being fitted correctly. Structural performance good, it's fine, it does what it has to. 2 hours fire performance, and it's the least expensive, as I said, way to build a cavity, to build a wall, but not necessarily the best value for money. So that really concludes today's video. There's more information on SIMS by Mannok on our website. The details are posted there on the screen. Or if you want to get in contact with us to discuss more of what you've seen in the presentation today, you can email us directly or give us a call. Details are on the screen. And thanks for watching today.